Okay, so we're going to do a video on dividing with exponents. And dividing is this rule right here. And you can see when the bases are the same, that you can take your exponents and instead of dividing them, we subtract them. Okay? And so that's what this whole rule today is going to be based around, is the fact that whenever we're dividing, we actually are going to subtract the exponents. So first off, I'm going to show you, and this might scare you off, but we're only going to do this once to help explain why subtracting works. M to the 6 would mean that we have 6 m's. So 1, 2, 3, 4, 5, 6. And we have 3 n's. 1, 2, 3. And then on the bottom we have 2 m's and 7 n's. 1, 2, 3. Oh, and you can see this is kind of a pain. And so the whole goal behind the rule is that you don't have to do what I'm doing right now. And so we want to show you why the rule works, but like I said, the major thing is we don't want to do this. Because imagine if this was m to the 20th. We wouldn't want to draw out 20 m's. So whenever you're dividing, when you have an m on top and an m on the bottom, then those cancel each other out. And so you can see here that this m would cancel out this m, and this m would cancel out this m, leaving me with how many m's? 4. 1, 2, 3, 4 on top. Well, we could have accomplished this same thing by looking and saying, okay, I got 6 m's on top, 2 m's on the bottom. I'm going to subtract them because these two are going to take away 2 m's from up here, and that would leave me with 4 m's. And then the question is where? And so here you can clearly see that there were 4 m's left. And if we were subtracting and we didn't have the picture, we always go where there's more m's. And so 6 minus 2 is 4, but there's more n's on top, so those 4 m's will go on top. And so it will be m to the 4th on top. Just like we have here, but without doing all this work. So we just simply subtract and keep it where there are more m's. So here, once again, just showing you, kind of this is the long way. This n would cancel out that n. This n would cancel out this n. And this n would cancel out that n, leaving me with 4 n's. But where? On the bottom, because we had more n's on the bottom. So once again, we could have done that without writing this out by simply doing, now notice, I always take the bigger minus the smaller. So 7 minus 3 is 4. But where does that 4 go? It's going to go on the bottom. So we're going to have n to the 4th on bottom, and that would be your answer. So I don't know if you remember in my last video that I talked about how I used to remember this when I was in high school. So I don't use proper terminology. These are called exponents, and if there's a number in front, that's a coefficient. But I always refer to these as the big numbers and little numbers. And it reminded me of big kids and little kids, and the fact that little kids don't get to do what the big kids do. And so we talked about when you're multiplying that we would multiply the big numbers but add the small numbers. Well, when you're dividing, you would divide the big numbers and you would subtract the small numbers. So I want you to kind of see a relationship between multiplying and adding, and then dividing and subtracting. And so as we move on, you're going to see we're going to have these big numbers. So like I said, these are called the coefficients, but I just always looked at them as big numbers and small numbers. And the big numbers are going to multiply. Well, the little numbers don't get to multiply. I'm sorry. The big numbers are going to divide, and the little numbers don't get to divide. So they're going to subtract. And that's just how I remembered this rule when I was a kid. One of the things I'm going to recommend when you're doing the big numbers is this is a fraction bar. Put it in as a fraction bar. And so you'll see that I've already done this. And I typed this in as a fraction and I got 4. But notice there's no fraction bar right here. And so that the fact that there's no fraction bar means that the 4 is going to go on top. So the 4 is going to go on top, and we'll show you when there is a fraction bar here in a second what that means. All right, so we let the calculator take care of this, and then we come back and we've got these x's, and so we're going to subtract, because this is division right here, so we're actually going to subtract. 12 minus 8 would be 4. So where does that 4 x's, where are they going to go? Well, they're going to go on the bottom because there were more x's on the bottom than there were on the top. And so we're going to put x to the 4th right there. So then we're going to come and take care of the y's. Once again, we're subtracting because this is division, and you don't really divide, you subtract. I was going to say because one's on top and one's on bottom, which is actually true. You know, when one's on top and one's on bottom, you're going to subtract. So we've got 3 y's here, and when there's no number right here, there's an understood 1, so 1 y right there. So we're going to subtract. 3 minus 1 would be 2. Where do we put those 2 y's? On top, because there's more y's on top. So y to the 3. And then we've taken care of the big numbers. We've taken care of all the letters and their little numbers. That's your answer right there. All right, we're going to take a look at one more. So once again, we're going to put these big numbers in the calculator with a fraction bar because that's how it looks. So I put in 18 over 27, and it gave me 2 over 3 with the fraction bar. What does that mean? That means that the 2 is going to go on top, and the 3 is going to go on the bottom. So when you type this into the calculator, and it gives you your answer, if there's a fraction bar, then whatever was on top goes on top. So 2 went on top, and then 3 went on the bottom. All right, now this problem has more to it than just the division. And so there was a rule, hopefully we know by now. If not, there were previous videos on it. And that is that we don't like negative exponents. And so anytime we have a negative exponent, we can make it positive by moving it over a fraction bar. So this x to the 4th is negative. I want to move it up over the fraction bar, and it becomes positive. So I'm going to go ahead and rewrite this x to the 3rd. It was positive, so I'm not going to mess with that. But that x to the negative 4 is going to come up to the top and become a positive 4. All right, well, both of these are already positive, and I'm just kind of rewriting this right now. So I'm not actually working anything out. I'm rewriting this so I can get rid of all these negatives. So now the z to the negative 5 will move up to the top to become positive, and the z to the negative 2 is going to move to the bottom to become positive. So we got z to the 5 on top, and z to the 2 on the bottom. Okay, so now, I'm not sure why I did that right there. Now that we have taken care of all the negatives and I've got nothing but positives, now we can work this out. Now the reason I wanted to show this to you is because, yes, we are dividing here. And so the big numbers would divide and the little numbers would subtract. But right here, I don't have x's on top and x's on the bottom. They're both on top, which means these, even though this is division, this is not being divided. When they're both on top, or even if they were both on the bottom, that means that they're being multiplied. So we go back to the rules that we learned with multiplying, that you would multiply the bigs but add the smalls. And so we are going to add, now this 2 over 3 we've already taken care of, that's reduced. So we're going to add these right here, and that would give me x to the 7th. So just because we're dividing doesn't mean that there aren't things that are being multiplied within it. And so this was being multiplied, so we actually add the exponents, and we get x to the 7th. All right, then we're going to subtract, because these are being divided, because one's on top, one's on bottom. So we're going to go 6 minus 2 is 4. And where did the 4 y's go? They're going to go on top because there's more y's on top. So we got y to the 4th. Okay, then we got 5 z's on top and 2 on the bottom. They're going to cancel out. So 5 minus 2 is 3. Where do the 3 z's go? On top, because there's more z's on top. So that would be our answer. We've taken care of the big numbers, and we've taken care of the letters and all their little numbers. So this is our answer. All right, well, I hope this video helped.